Well, welcome everybody to our monthly Spatial Analyzer New River Kinematics webinar on sort of all things SA. We started this at the beginning of the year, and we're doing a webinar about once a month. Actually, it's exactly once a month. On the first Friday of the month, you can find us. If you're subscribed to our email, we'll send out the link the week ahead, just to kind of let you know what it's going to be on and when to tune in. But it's the first Friday of the month, 1 p.m. Central Time. And it's the topics kind of vary, and the goal is to keep it pretty short. So this is going to be about 30 minutes, and keep it relatively interactive. So for everybody that's joined in the meeting, if you have a question at any time, please just jump in there and say, hey, could you show me that again? Or, well, what about this particular situation or something like that? Just whatever you have. We want these to be informational and a little bit casual as well. So feel free to jump in at any time if you have any questions or if you need me to repeat anything. And like I said, what we're doing is we're covering a pretty simple or straightforward topic every Friday. And we'll kind of start with the easy stuff, and we'll dig down a little bit until we get into the little bit more complex stuff as well. And with that being said, this month's topic is alignments in SA. And so let me just introduce myself really quick. My name is Caleb Canal. I'm one of the application engineers for New River Kinematics, and I live in Tyler, Texas. I'm currently quarantined in Tyler, Texas for the foreseeable future. And I grew up in East Texas. I graduated from Laterno University and started work at General Dynamics in Kilgore, Texas in the SATCOM division. I saw earlier that Jay Ditzworth was on there as well. And so he's an old colleague of mine from back in the GD days. But that's where I learned a little bit about metrology and kind of got started with trackers and software, et cetera. And then about 6 years ago, came across Spatial Analyzer and started working with New River Kinematics from General Dynamics, and just really enjoyed the atmosphere, the company, and just the attitudes of the people that I worked with at NRK. And it was just really refreshing. It seemed like a pretty cool company. And so they had an opening that came up in 2014. And so I started working for them full time from Tyler. And just a little personal note, that was also the same time that my wife and I adopted 2 kids as well. We already had 3 biological, and we adopted 2 kids the very same month that I started traveling primarily for work. So it was a big life change all at once in 2014, but we made it through, and it really has been just a fantastic place to work. And the kids are doing great too, if you're interested. So our family is a big family, but that's really made the quarantine more fun for us. So we've been trying to get out and do like family bike rides or family walks every day. And so we're just trying to keep it, as routine as possible. And hopefully pretty soon, especially if you live in Texas or I think Georgia, going to be turning things loose here pretty soon too. So hopefully we'll see you guys all in the very near future. But with that being said, we're going to jump right into alignments. And I just want to show you a few alignments that are built into SA. SA is a portable metrology, and we always have been portable from the very beginning. And so one of the strengths of our software is the ability and the versatility of our alignments that are possible in the software. So there's a whole bunch of different alignments that you can choose. And just to see a few of them, you can right click on your tracker, and you can see these are kind of like the top, dozen alignments or so that people use on a day-to-day basis. And then also you can see some of the more frequently used ones here in the alignments tab. But I just want to go through a few of the really, really simple ones and just show those to you. And then we'll get into a few more complex ones as we go along. And I promise you that by 1:30, we'll be wrapping it up too. Okay. So the first thing I want to do is an alignment called a quick align. And a quick align is a very simple and straightforward alignment. So I'm just going to take my CAD model here, and I'm going to add it to SA. All right, so this is a demo part that we just recently designed and started using here. And so it's a relatively flat part, and it's got some features on there as well. And so in order to perform a quick align, it's very simple. You just want to select quick align up here, or you can right click on your instrument and select locate quick align. So any way that you get to it, you still get the same dialogue, and it's really easy to get to. Now, a quick align is generally works best with a 3-2-1 type of alignment. So I'm going to pick 6 points, but I'm going to be sure to be a good metrologist here. And I'm going to select those points on a plane, line, and point. So I'm going to use this big top surface as my plane. I'm going to use this edge over here as my line, and I'm going to use this edge right here as my point. So now that I've got 6 points, I'm going to hit enter, and it's ready for me to go ahead and start measuring. Now, if you had already inspected your part and you included these 6 points as a part of your measurement, you could actually just pick those 6 points in sequential order and it would align for you. I've got an instrument right here, so I'm going to go ahead and you'll see me leave the camera. I'm just going to go over to my part and start measuring those points right now. So I've got my part fixtured to a table here, and I know you can't see me, but just trust me that what you see on the screen there replicates exactly what I'm seeing over here. And I'm just going to select the point on my surface and go ahead and hit measure. And you can see as I measure, the screen updates to show those targets with the next available point. That's 2, 3, and then we'll move over here to the side, 4, 5, and 6. Now, what you want to look for when you've completed your 6-point quick align is that your RMS and your max deviation should be 0. If you think about it mathematically, statistically, a 6-point alignment 3-2-1 is a perfect alignment. So if you see anything other than zeros there, then that's probably a red flag. You want to just go ahead and repeat your quick align. I like that look there, so I'm just going to hit accept. And then just to prove that I am aligned to my part, it's really easy to bring up a DRO, or what we call a watch window in Spatial Analyzer. And so I'm just going to bring up a watch window on this entire part. So I'm going to hit add watch window. And now you can see from the current location of the arm as I go back over here to the part. And then as I move around the surface, you'll see that my watch window updates in real time with my alignment. And let me just move that window a little bit so you can kind of see the gray arrows there that are kind of updating with the direction of any deviation that's found. So that's just a great way to, a quick align is just like a super fast and simple way to get into your part coordinates. And it's also, really straightforward. But just to, give you a little bit more information, you got to think about when you're performing a quick align, how sensitive your alignment is to any one of these points being wrong. So if I were to have taken this 6th point in a part on the surface where there was an error, that 6th point is the only point that I'm using in order to orient my part in this Z, that would be the Z direction. So any error in that point or in the surface of the part right there is going to translate directly into Z error. So that's why it may be beneficial to you as you perform your quick align to, instead of just selecting 6 points, select additional points as well, and you can do that while you do it. All right, I'm going to go ahead and move on to the next type of alignment, which I'll cover is called a cloud to CAD alignment. So I want to show you what that looks like really quick, and we will do this with a new instrument. So I'm going to move my part, and anytime you translate or move part or instrument in Spatial Analyzer, you want to make sure to add it as a new instrument in your job file. So I'm just going to select jump instrument to new location. If I wanted to locate that instrument, I could at this time by using these 2 particular types. That's not one of the ones that I'm using, so I'm just going to hit OK there. And then I'm going to go to my part, and I'm going to begin. Let me select one more thing here for clouds and surfaces. I'm going to prepare a clipping plane. Okay, so we've got our clipping plane. We'll go to next. There we go. So it's going to automatically hide that clipping plane and generate a new cloud called default cloud. So we'll just begin scanning, and you'll see the part start to develop here really quick. It's going to get some scan data on the edges. And, it's critical when you're doing a cloud to CAD alignment that you get a good coverage on the part. You don't have to get 100% super dense data, but you do want to get good coverage on the part so that way it can perform a really decent alignment to your CAD model. Let's get a little bit more on the edge there. And there. Okay. So now I've got my scan going, and you can see that we got a really decent scan of our part there. So all I've got to do is just right click on the cloud and select Align to CAD. It's going to ask me to pick my surfaces, which I've hidden. So let me go ahead and show that again. And I'll just pick that surface and hit enter. So very fast, SA is going to mesh the surface, perform the alignment, and also give you the residuals for that alignment as well, the translation and the rotation and everything. So now I've got a great alignment in my cloud to CAD, and I didn't have to do anything more than that. So that's a really, really simple way to align as well. It's really fast as well. Okay, let's continue on in this particular job file, and let's talk about another type of alignment that's called best fit. Now, if you've done any type of fitting in SA, you're probably familiar with best fit. That's probably the most popular way of fitting into a set of reference targets or into a tool or something like that. Let me hide these points, and what I'm going to do is I'm going to bring in my reference data. And what I'm trying to approximate here is if you have a tool where maybe you've got some tooling balls, and I'm imagining these points here are like 1/4 inch pin nests or 1/4 inch holes, and then we're just going to select a tooling ball above them. So what I have is a set of reference data that I want to bring in on top of my part. Now, SA supports really good model-based definition, so you can have these all saved together, but I just happen to have them in a separate file here so that we can bring them in separately. So I don't know if you can see that, but we've got some point data that's right above those holes. So what I'm going to do is I'm going to go ahead and measure those, and then I'm going to perform a best fit to those reference points. So I'll just call this my TBs. Shout out to the tooling people that are measuring tooling balls, and I'll just start with 1. Okay, so now with that set, I'm going to go back over to the part, and I'm going to begin to measure these as probed points. So any questions so far on the quick align or cloud to CAD alignment? Okay, I think I'm ready to start measuring here. So I'm just gonna, I've also, yeah, let me go ahead and, what I need to do is add another instrument because we're actually at a new location now. I'm gonna jump instrument to new location. I'm not gonna do anything there, and we'll hide that. Okay, now we're at our new location. We're on our tooling ball point group, and we're ready to measure. So I'm just gonna measure each one of those 7 holes. Now, it's not performing any real-time alignment here because I haven't actually told it to align. I've just measured the data that I'm going to use for my alignment. So you can see my part is over here now, but my measured holes are over here. Now, if you haven't updated SA in a little while, you may be surprised to find that you don't have to have your points labeled the same anymore for a best fit. We can actually figure that all out for you. So you can see I measured my points in a certain order. I didn't use the same nomenclature, not PT1 or anything like that. But when I go to perform my best fit, which I'll go to alignment, I'll select best fit, and we'll do points to points. It's going to ask for the reference group, which is that group of points that I just imported, that text group. And it's going to ask for the corresponding group or actuals. I'm going to double click on there. Now, this is a new feature that came out last year. And I think our last release of last year. And what this says is it's basically saying, hey, you asked me to perform a best fit, but I don't actually have any points that are named similarly. So which of these do you actually want to rename? I'm going to leave my nominal data the same, and I'm just going to rename my tooling ball points. So what it's going to do is going to look for interpoint distance matches. So I'm going to hit OK there, and you can see that it's chosen a rename of these points. And I did actually measure them in that order, but that's not actually critical. So I measured them in the correct order, but I didn't name them correctly. So 1 goes to 1, 2 goes to 2, etc. So I'll just hit accept, and you'll see these point names will update really quickly as well. And then we get our best fit dialog. So now I've got my point names correctly, and I can refresh on my best fit. And this is actually a really great fit here. I'm less than 2 thou. And just so you know, the part that I'm aligning to is actually a 3D printed part. So I don't expect machine tolerances on this. So I'm really happy with these. But in the best fit dialog, if you do have anything that you would like to adjust, then you can just deselect points. So this would be my worst point here at 2.5 thou. I can hit refresh and then just fit with just the other 6 points. So however you want to do it, that's all possible in there. And then another thing that you can do is scale, and you can adjust scale. So if I adjust my scale, I just want to warn you to take a look at your scale factor and make sure that it's something that makes sense. So for a 3D printed plastic part, that's probably accurate to the amount of change. It's a little bit warmer in here this afternoon than when I originally measured these location points. So we'll just leave that like that, and we'll go ahead and hit apply transformation. So what it does is when you've done the best fit, what we want to do is we want to move our instrument as well. And if you want to have a reference for where you were before this, in this case, my current location is not really anything that I need to make a record of. But if you didn't need to make a record of your current position before you moved to this new position, then you could make a copy of the working frame. I'm just going to hit OK. It's asking me which instrument I want to perform. I want to transform. So I'll select that and hit enter. And now I am aligned to my part, and I won't go through the watch window to prove that, but you can see now our points names match up and their locations match up as well. Another thing that is important in this situation is that whenever we do an alignment, we want to make that traceable. So if you do have to report out your alignments and your residuals from your alignments, you can always go to your events category and you can select your best fit transformation or whichever instrument transformation alignment that you choose. And that data is going to can be added right into your report. So if I go back and I look at this, I can see which points I used for my alignment and what the deviation was for those points from their nominals. So that's really great information as well. Okay, and then the last one of these simple alignment types is doing a measure nominal points. And really, this is mathematically the same thing virtually as performing a best fit. It's just a dialogue that helps you walk you through the process of measuring so that you don't miss anything or so that you don't have to worry about naming stuff correctly as well. So again, best fit kind of takes care of that now, but this is also pretty helpful. So I'm just going to go ahead and one more time jump instrument to new location. And this time I am going to select one of the quick select ones for measure nominal points. So I'm going to check that, hit OK, get this measurement out of our way. And it's going to ask me to select my nominals. I'll go ahead and pick that text point group. And then I'll look here for the list of points that I need to measure. So one of the handy things about this dialog is after measuring the first 3 points, it can actually automatically rename the points no matter what order you measure them in. So it's just going to kind of walk you through the process of measuring. If you're unfamiliar with the particular job file that you stumbled into, and you may not be, aware of where all the points are, this gives you a kind of a list to check off. So I'm going to go ahead and go to point 1. I'm just going to grab my arm, and I'm going to start measuring. And as soon as I measure the first 3, you'll see those amount of deviations pop up. And then I can measure the remaining points in any particular order that I want. So I did 5, or what was that, 6, 7, 5, 4. And if at any point you don't like one of those measurements, so let's see, 0.7 is our worst point there. You can just go right back to that point and hit remeasure. And you can remeasure it as many times as you like. And it'll just overwrite the previous point until you get to something that you like. So that improved a little bit with the next measurement. So I like that. I'm just going to go ahead and hit finish, instrument locate. So those are quick align, best fit, cloud to CAD, and measure nominal. Those are really simple and very fast alignments to use. The next section that I want to talk about for just a couple minutes here is alignments that are a little bit more complex. And in order to do that, I'm going to open a sample file, which everyone should have built into every installation of SA. You always get these sample files. This one is particularly called MP analysis demo. We're not going to be using any measurement plans, but we do want the job file that's available in here. So a relationship fit is a more advanced form of alignment. And it's where you would take a set of points and you would compare them to a nominal or a CAD surface. And then you would allow SA to move the instrument or the object until the deviations between those points and that surface is optimized. So the first thing that I want to do here is just create a new type of relationship called, well, it's not new, but we haven't talked about it today, a type of relationship called groups to objects. So that's under the features menu, under the points category. This is called groups to objects. I'll just pick that group and hit enter, and I'll just pick my object and hit enter. And I can render that solid if it helps you to see that a little bit better. But now you can see where our points are completely off the surface, and we need to optimize those point locations. So in order to just make this a little bit more obvious, I'm going to turn on a vector group between those points and their correlating location on the surface. So we got some really big deviations, obviously, because we're not aligned. But now we can take our instrument and we can locate our instrument, coming back to this, most frequently used type of alignments, and we can use something called minimize relationships. So I'll just go ahead and pick that. And you can see right now we're sitting at about 1.5 inches off the surface. This relationship, particular job file, just allows us to show one relationship and how when we optimize it, we get much better surface deviations from our part there. So one of the things that you'll get from this dialog is you can restrict the degrees of freedom that you allow your instrument to move. So for instance, if you're working with an instrument with a very accurate internal level, then you may want to exclude RX and RY, and so that it won't rotate about, the gravitational vector. But if you don't need to do that, you can just hit one relationship, run optimization, and you're good there. Run direct search optimization is a little bit more advanced way of solving these same mathematical equations. And if you'd like more information about that, we have our advanced class, which kind of talks about how that works. And I'll just point you in that direction, or send me a message afterwards and we can talk about it. So I'll just hit apply transformation, and we've done a relatively good alignment there. The next one that I want to show you is when you have multiple relationships and how SA can simultaneously resolve those multiple relationships. So I'm going to pick the relationships job file, also in sample files. And you can see we have the same part here, but we have a slightly different setup in our arrangement of these points. So now instead of one point group, we actually have multiple point groups and multiple relationships. So if we go back to that locate dialog, minimize relationships, now you'll see instead of optimizing a single relationship, now we can optimize all of these relationships. And what you'll notice is that some of them have more points than others. And in order for us to get good results, what we want to do is normalize the weighting. And that will take out any factors that apply to some relationships having more points than other relationships. So I'll go ahead and do that, and then we'll run optimization. And what you'll notice here is that it's kind of difficult to see, but that we have one point on this relationship that's called center line. And if I turn on hover mode, when I hover over center line, you can see that it's this plane here, and there's a couple of points here that are off, and we've got a pretty big deviation there. I happen to know that one of those points is an outlier, and so I want to not include that point in my solution. So what I'll do is just right-click on the relationship and select outlier rejection. And what I want to do is, because I know that I should expect these points to be relatively close, I'm going to reject all points that are more than 10 thou out on the deviation, and I'll hit OK, and then I'll run this optimization again. And now you can see that with that point disabled, we actually get a really great result on centerline because we only have, I think, one point on there now. And we're rejecting that outlier. It also allows the other relationships to fit slightly better. So one thing that's a little bit more advanced, but we won't cover today, is something that's called fit constraints. And fit constraints are a way of saying, if I have a relationship that I know needs to be within 20 or 30 thou of like surface profile, then I can add that as a fit constraint. And as soon as the solution gets to within plus or minus 30, and I've got to put a minus on here, what it will do is stop trying to get that any closer to zero. And so really it kind of creates a dead zone where your points will no longer affect your solution if they're within their tolerance. And that is a very powerful feature of Spatial Analyzer, to take a part that should be failing, but because you loosen up your tolerance, or not loosen up your tolerance, but use up the most of your tolerance in other relationships, you can actually get those more critical relationships to pass. All right, so I know we're at 1:30 and we should be closing up here. I want to show you one more example file about another type of fit that you can use that you may not think of as an alignment technique. So if I go to my, let me just open this one more file here really quick. And while I'm looking for it, does anybody have any questions about any of those simple alignments or the more complex alignments? Let's see. I need to go to. Okay, so this is another survey here, which we just kind of fabricated some data for, where we're surveying a part, but in order to get full coverage on that part, we really need multiple stations to perform the alignment. So what we've done is, in a time critical situation, instead of performing a best fit or a measure nominal on each instrument station, in order to make the best use of our time, we just went with each station and just measured the reference network, the control network, and the survey data that we needed all at the same time, and then just jumped to a new location. So one of the things that you may not think about as just an everyday type of alignment is our USMN feature in SA. So USMN is a very accurate way to create an alignment network. And I can use this to align these other two and actually get better fit results than I would with just best fitting them and doing sort of a leapfrog around the part. So I'm going to select all my instruments for this USMN. I'm going to hit enter and I'm going to hit OK. And then I get, I forgot to, I need to not include a couple of my survey point groups. Okay, so I just want to uncheck my survey point groups because I'm not going to use those in my alignment, even though they will be moving with my instruments. We'll hit OK there. Yeah, now we've got our USMN. And all we've got to do in order to get a really good and accurate best fit is just hit our best fit then solve button here. You'll notice that station 1 is not moving. So station 1 is going to remain in place and everything else is going to move to station 1. But when I perform that alignment, I can see that I've got a little bit of an error on this 0.109. It's using up 123% of our uncertainty range. So I'll just go ahead and trim that as an outlier one more time. It says it's going to trim 109, instrument 0. And then we'll go ahead and solve again. So as you begin to trim observations on points, your ranking updates. And if you'd like to know more about USMN and how it works, we actually have a really good video on our YouTube channel. So I'd encourage you to go take a look at that. But what we get with this is a very accurate placement of our instruments in the control network. And then all I've got to do is hit apply here. And all of my instruments, along with their survey data, are going to snap right into place using that USMN. Now, I didn't go ahead and create the composite point, but outside of alignments, if you're looking for a way to very accurately specify your control network, then USMN is really the only way to go when you're trying to do that, because it takes the best observations from each instrument station and is able to find out the most likely location of each one of your control points, not just averaging out your control points over all observations. So it's a really easy way to do it. There's a few more alignments that we didn't get to, but if you'd like to know more about using a GD&T alignment or using an RPS for relative point system or sequential alignment, those are all built into Spatial Analyzer software as well. And in addition, there's more in there about fit constraints that would be really beneficial to you. So, but in the interest of keeping this webinar pretty short and sweet today, that's all that I've got. Does anybody have any questions about anything we've covered so far? I know it was a lot of stuff.
Looks like Jay had a question. Richard was answering it, but he was asking on a locate instrument through nominal points. Do the first 3 points have to be done in order?
Yeah, let me just go back and show that really quick as well, because that's a good question, Jay. If we select the instrument, go to locate, measure nominal, and we're going to use our reference point group here. So you don't have to do points 0, 1, 2, and 3. You don't have to do them in that order. You could select them in any order that you wanted to. But the key thing is you do have to tell Spatial Analyzer which point you're measuring at the time you measure it. So if you're working with a tracker, now what you'll want to do is you'll want to put your SMR in the nest. You'll want to select the nest that you're at, and then you can just hit measure manually. Or if you're using stable points with the tracker, you'll want to either measure them in order so that the stable point will go from one to the next, or just go back and forth between the computer so that you can say, okay, now I'm measuring 8, now I'm measuring 1, now I'm measuring 7. As soon as you've completed that with 3 points, all the rest of them you can measure in any order, and SA will figure out what goes where. But the first 3 it does need in order to locate itself.
That's all the questions that have been brought in.
All right. Well, thanks for joining us, everybody, for this webinar. Be sure to jump on the first Friday of June. Hopefully things will be moving back towards normal at that point. But if at any time you need help from us, or if you need have any questions that need to be answered, Ben, if you don't mind, would you post our booking site there in the chat as well? We've got a great website that you can go to, and you can click on this link that Ben's going to share, and then you can sign up for a time with an AE or with one of our regional managers, and you can have just an hour devoted just to whatever questions that you have. And that's open, that's available to anybody. So if you have any questions, I'd highly encourage you to just click on that link, set up an appointment with me or Richard or Anna or Drew, our other application engineers, and let one of us help you walk you through this. We're doing a lot more online stuff now, so it's really easy to just, whenever we're available, just jump on and provide support over Microsoft Teams, which is obviously what we're using now. If you prefer another video conference service, we can use that as well. But whatever makes sense to you, just jump on there. If you have any questions, we'd love to work with you on particular projects or particular difficulties that you're experiencing. However we can help out, that's what we're here for.
All right.
Anything else we need to say, Ben?
Fantastic. Good job.
All right. Good deal. Thank you guys so much for coming, for participating. Thank you for being SA users, and hopefully we'll be out there and we'll be working with you very soon. Everybody have a good weekend, all right?
Have a good weekend. Thank you.